Oftentimes, we will be asked to find the volume of a solid whose axis of revolution is a line other than one of the coordinate axes. We can use the same method of disks or washers to find the volumes of these types of regions. So in our first example here, we have the equation y equals e to the x, y equals 1, x equals 2 that creates this region. And we want to rotate it around the line y equals -2. Well, this line y equals -2 is parallel to the x-axis, so it will be set up the same way as if we rotated it around the x-axis. That means the height will be dx of my cross-section. And I can see there is a hole in between my region and my axis. So that means that I will need a washer, which means I need to look for a big radius and a little radius. So my larger radius is going to go upper minus lower, e to the x, subtracting our axis of revolution. And our little radius starts from here, 1, subtracting our radius, or our axis of revolution, 1 minus -2. So now to set up my volume, it's pi integral from 0 to 2, of my big radius squared, subtracting my little radius squared, multiplied by my height. So here in number 2, now we're rotating around the line x equals 2. So if I rotated around that, it would actually create a solid shape. So that means I can use a disk. Now, if I rotate around this line x equals 2 is parallel to my y-axis. So it's the same setup as if I rotated around my y-axis. Now dy is my height. And I need my radius. Here's my sample radius here. So that radius that's rotated around here, it needs to be in terms of y. So our original equation is y equals e to the x, so x equals ln y. So that means my radius is this distance here. And in order to calculate that distance, we always do right minus left. So our radius, our only radius, right minus left is going to be 2 subtracting ln, ln y. So be careful, when you set up your radius, it should always be right minus left or upper minus lower. So now I can set up my volume, pi times the integral. Okay, well, what's our lowest y value? Well, it looks like our lowest y value is y equals 1. And my highest y value is up here. That's going to be e squared of my radius, which is 2 minus ln y squared times my height. Now, last but not least, we have this same region rotated around the line x equals -3. So x equals -3 is parallel to the y-axis. So that means it's the same setup, which means that my height is going to be dy. I can see that there is a hole here between my shape and my axis of rotation. So I need a big radius and a little radius. Now my big radius is always right minus left. So that in this instance is going to be 2 subtracting -3. My little radius or inner radius is going from this curve to my axis, right minus left, and that's going to be ln y minus -3. So now I can set up my volume formula. Volume is pi times the integral. It's still the same y's from 1 to e squared of my big radius squared subtracting my little radius squared multiplied by the height. So we can rotate about different axes of revolution.